I can't wait to see what everybody's birthdays look like.
And post it later because I want to explore it because I
Sure,
don't
no problem.
like what I made.
I'm
Guess-
July also.
I got a July.
Okay, why don't you guys go ahead and show your videos real quick.
Okay, do you want me to do it first?
Sure, Vic.
Okay. We got it?
Wow. Look at all your flares. Awesome.
Good.
Jennifer?
I wasn't going to take any time out of it, so I didn't finish my movie either. I'm
Oh,
kind of
that's
like
okay. No, that's
17. I'm gonna mess around more with the opacity piece, so I'm good. But I will post
Okay.
one with you. Thanks.
Jennifer Miller, did you say you had a July birthday too?
Yeah, July 2nd, and mine is still processing. So I'll
That's
post it shortly.
I'm
All right.
glad I'm not the only one.
No, it takes a lot of bandwidth. Lindsay, did you end up making one? Do you want to share?
I had one and then my Safari crashed, so I don't, it might still be in there if I can get it linked up, but I can't show it right at the moment.
All right, Laura, Chris, or Tasha, do you have ones? Or Wendy, I don't know if yours is done now.
I can go
Okay.
as soon as I figure out what I'm doing.
So if you know when your students' birthdays are at the beginning and you can get it lined up and have everybody share those, you can have this lovely conversation about what is the sun doing. Yours is really red.
You guys see it?
Yeah.
Oh,
See
good.
all those active regions. Wow.
Yeah. It's like it's just pregnant waiting for something to happen.
It's a little bit longer. I did 2 days.
Excellent. Thank you. Wendy or Tasha, did you want to share yours? Or we might be out of chronological order, but
I can do mine. I think I put it on the Ouija.
great.
I don't know.
I mean, we can look and see if we see it.
I don't know where I am.
Oh, I see yours. Yours is at the top. See Lynn's and Diane's and Laura's. There's the winning cow.
Yeah. Yeah. Yeah.
It was exciting.
One of the steers. I didn't. How do you get all those tags on it and everything?
You would have to you'd have to remake the movie, Wendy. So you can do that the next time when you're finished here. You can add those tags in afterwards, and then you have to recreate the movie.
All right. Pretty cool. Okay.
Yeah, you definitely have some action. Awesome. Oh, I see the chat. Now my chat just came back up. So Tasha, no worries at all.
Oh, I think I missed it.
You missed what?
I'm trying to do it on another computer, and it's just, yeah. I'll have to
It's
do
all good. No worries at all. But we can kind of see how we'd be able to have a comparison of looking at when those active times, even if we didn't have access to the data, we could make predictions and or make observations and comments on what our sun did throughout the year. And then you could use other tools to go back and look at the data and other places to look at those things. So that's just one way to use HelioViewer. Thoughts on using it, or or any of those pieces? Before we have Jennifer show us more about what she has in her curriculum package for us, but thoughts about how you could use it or what things you discovered in using it?
Did anybody play with the coronagraphs? Adding Lasco to your movies or anything like that?
Claire and Laura did.
Or what about if you didn't use any of the coronal images? So if you don't use the EUV images and only look at the photosphere, so you only look at the sunspots, then do you think that would be very different in a result if we were sharing throughout the year? It would be much easier to count the number of sunspots at each time, for sure. And you could even do that as a still. You wouldn't have to make that a movie. You could just make that a snapshot of an image. And then you could count the number of sunspots through the year and see if that varies. Or you could have each student take a snapshot of their birthday for 5 years. And then if you could create a graph of the number of sunspots over 5 years and see if you could start to see that the increasing solar cycle.
Those are all awesome ideas. Yeah. Any other thoughts that teachers have had? I mean, just jump in, guys, or maybe you don't have any thoughts yet, or what things might you need to keep in mind in using it with your students?
When I've used this with my students, I was using the J-Helio viewer, but it's the same thing. It's been super helpful in just the basic understanding that the sun is not a constant blank yellowy surface. And most of them, if you give them even just a day to play with it so they can see that there's so many other things happening, then you can use it as a start-off spot to jump deeper into the different topics of different types of features or events or sunspot counts or solar cycles. They have something to go back to, and they understand that it's a super dynamic place. And they typically ask good questions that get the result of, I don't know. And they also understand we don't know all of it.
I'm planning on using it to go backwards, I guess. Try to find when there was aurora in Wisconsin where it was visible. It's always cloudy. And then have the magnetometer signature because of the aurora. And then go back to the sun and try to find the event on the sun that caused all of that to happen.
I love that idea, Wendy, especially if you do include the coronagraphs, and then you'll have not only the magnetometer data at Earth, but you'll probably have to go back a day or two in order to find the event on the sun. You'll be able to track the time if you're looking at the C2 coronagraph, or the C3 coronagraph, which is the one close to the Earth, that should be around the time of your magnetometer signature. And then you can track that CME back in time to the sun, which is probably about 18 hours to 2 days before you actually start to see the signal on the Earth.
Yep, that would be cool. That's my plan.
Could you, along those same lines, I was wondering if you could use some of that satellite information you were talking about you could look up if you wanted to, but isn't useful. Could you use that to get any indication of maybe when the CME hit the detectors? Or would that be information we'd need to pull in from different places?
You wouldn't necessarily be able to see when it hit the detectors, but you could see that with your eye. So there's some coronagraph movies with all of the salt and pepper effect. They get all bitty from cosmic rays or CMEs. So if you can see that effect, then they've been hit by detectors, but they're usually the more powerful storms. You could look up some other resources such as ENLIL, ENLIL. that is very much a scientific database, and they don't provide information for every single event, but you could see if there was information for that. The Space Weather Center, SWPC, is also another great place to go for that kind of information. But yeah, you could definitely look for ancillary data to try and build your case. You could build a real live Mystery of the Sun kind of activity from the space science sequence. And then so the information that I was talking about that may not be particularly useful was this stuff here. And it's not that it's not useful, it just, depending on your age level of your kids, it might be overkill. So it's this right here, and it's the metadata. So it's got, you know, the origin, the continue intensity, the build version, all of the specifics of the image that you're looking at. You know, it's a lot of information, and most of it is not helpful. Possibly this last little segment on history and comment, but the rest of it I wouldn't overload your kids with unless they really wanted to. But the rest of the information that you're talking about then, Laura, I think that would be really helpful.
I want to just share real quickly about the SWPC sites. So just to go there, I think if you're looking for good information would be, you can go back up to, what are we, Sunday now? Weekend just flew by. So several days in the past, which is, it takes, like, you know, depending on the speed of the CME and what's happening with the solar wind, you know, 1 to 4 days for space weather events to hit our planet if everything's aligned right. So if you go to G, this is the geomagnetic storm, and this is kind of the forecast.
Can you share, Jennifer?
For, oh, I thought I did. Sorry.
Yes.
Let me go back here. Desktop. Share screen with sound. There we go. Okay. So anyhow, you know, just from a point of view of having understandable information that's not dumbed down but accessible to people, I would say this is really a great site I would use. And if you click on the G, it's the geomagnetic storm forecast. And if you go to the NOAA scales, that's kind of like the, you know, we're all kind of used to this Homeland Security deal with the green, you know, yellow or orange, red. So this explains, you know, well, what level of potential are we in for a space weather event hitting the planet? So I think this is really great because it's, you know, gives you back to, you know, several days in the past, but also can give the prediction piece for the current day, etc. Even into prediction into the future. So G is for the aurora, solar radiation storms, which is, I believe is with the flares. Maybe I'm wrong. Claire, fix me if I am. And then you've got issues when you've got radio blackouts. So this is all explained within the site. And I think it's a nice time with HelioViewer, making it understandable as to what's happened, what will happen, what is happening.
Excellent. I'll be using that for sure.
I had an idea, and this is new to me, so I just want to kind of see what you think. That once the kids do pick their birthday and they see the pictures of different phenomenon going on in the sun, then I'm thinking of really wavelengths, because I'm teaching chemistry. So I'd like them to think about, well, what kind of filters would be best to view the different kinds of phenomenon? Is that, and then they would go back and then take another picture based on different things come at different frequencies.
That's a good idea. And one of the slides that I'd shown in the tutorial has some of that information that you could have them start with. You have to remember that the laws of physics on the sun are not the same as on Earth, so it's not a linear thing. So like the Rayleigh-Jeans law doesn't really apply in the corona or anything like that. We have a magnetized plasma, so it's, for those of you who are teaching physics and chemistry, it's not as linear as you might otherwise like, but there are definitely general relations that you could have them explore. So yes, I think that's a great idea. Sorry, Jennifer, I think I may have cut you off. Were you going to say something?
Well, I was just going to say it's a good lead-in just to kind of quickly explain like how the 2A module was put together. And again, I could just, you know, share that. And I know we're supposed to finish, what, another 15 minutes or so. So okay, Andy, to kind of do this element?
Yep, absolutely. Go right ahead.
Okay. So let me go ahead and share the screen again. And everyone should have, this PDF was sent along with a a Word doc of the HelioViewer data sheet that you can either do, computer-based or print and have them fill it in. And that was the whole point, Diane, was to try to make it relevant. So we're learning all this stuff as students, we're teaching all this stuff as teachers, but what's the real-world application of the electromagnetic spectrum in relationship between the Sun-Earth interaction? And so basically what you see on the teacher guide is the students' versions on the left. So they're not going to have all your little notes here, which you can use, add to, or whatever, which kind of puts it into context. So the whole idea is that we're not putting a ton of imagery in here, that the student will, through their use of the resources in each activity, create that knowledge base. So this is, a lot of information from NASA, for instance, on the EM spectrum. But what does this mean in relationship to the Sun-Earth interaction? So a couple of paragraphs of an overview, background information for an educator, and then what are the key objectives for each activity, and then the key vocabulary that the students will have to, get familiar with through their, their direct instruction or however they want to approach the vocabulary piece. And then the science behind STO that helps teach that concept, i.e. the electromagnetic spectrum. And so with this one, it's mainly AIA and EVE. And then there's a team goal, a one-sentence goal with here's what our purpose is trying to achieve having gone through this activity. And again, this is team-based rather than individual. You obviously could do it as an individual, but just having the mind power will make it that much more rich. But I also feel that if you have different groups working in different activities, it keeps your sanity because you're not trying to do 30 different individual groups. You may have only 4 to 6, and I think it's much more manageable. So this was kind of looked at as a 2-block, 4-class period activity. So you're not rushing through it and getting a meaningless experience. So the materials are clearly spelled out. The links to all the resources are here, which mirrors what the students see, and so they have a much more, direct, do this paragraph and then follow through. And it's again following the 5 E's. I feel most people are familiar with the 5 E's, and if you're not, it's the BSCS. I forget what that acronym stands for, but they're down in Colorado Springs, the biological sciences curriculum something, but they seem to be kind of the approach NGSS has adapted with how to make NGSS work. And last count that I can remember, I think it was like 18 states have adopted NGSS, unlike how many took on Common Core. And the main reason for that was a funding difference. States that adopted Common Core got funding. There's not that incentive there for the NGSS, but NGSS has a great approach to scientific investigation and the process of science, and having it be the experiential investigative approach. And so here's what the students would do as a building the background. They have nothing, no clue about this. Well, what is STO? What's on it? How are they finding out what's going on from the EM spectrum point of view? So trying to take this high-level science and, again, not dumb it down, but make it accessible. So the introduction of wavelength, it's crazy that we're working in angstroms. We keep telling our kids, work in the metric system. So having that connection, say, for units is a great little tie-in that you can expand upon and use STO to help address, that part of scientific understanding and learning. And then again, just the video links are directly here. There is, as I mentioned earlier, an appendix that has every single URL spelled out if by chance you want to know all that information too. So the students would watch these videos and understand, well, what part of STO is working in the electromagnetic spectrum to get its data. And then this kind of is a great image that if you go to the STO website as well, great gallery of resources, images, movies you can download of what each image looks like in the different wavelength, and again in the angstrom. And as Claire mentioned, it's 10 to the minus 10th meter. A nanometer is 10 to the minus 9. So you would just move the decimal one over to the left. So this would be 9.4, 13.1, 17.1 nanometers. And I love the visual that Claire had put together. And Claire, that's definitely going to be incorporated and credited to show what part of solar activity is related to what specific wavelength. And that was something, that wasn't really available on the STO site because it is geared a lot towards scientists and people that have an understanding. They're saying numbers 211 and whatever, but nobody knows, well, what unit is that? And had to work backwards and find that information out. And
I would reiterate that it is an art rather than a science, so it's not a cut and dry thing, but it's definitely a good place to start if you're looking to see what's good for seeing what features.
Right, and so like Langley had with their instrument is AIA, sorry, I forget the LAMSP, I don't know what the L stand for, I get they all meshed together. But anyhow, they had a great table, which again, I added the nanometers to the angstrom piece, and then there's links that go to their website, and it tells you what part or the region of the sun and its chromosphere that you're seeing, you're seeing these different solar activity, events happening, and what it is that you're picking up. Like, for instance, where are the flares, and what's happening in the transition region, et cetera, et cetera. So you can get as much detail as you want, especially if you want to bring it to the high school level. And so then when the kids then get an understanding of the instrumentation, then they're going to apply that. And so there's, again, a tour, which is a great one through NASA on just an interactive tour. I'm not going to go through the whole thing, but a great resource here, which has a lot of additional information that you can build upon, have as a self-directed tutorial for students to follow. What the heck is a wave, et cetera, et cetera. So, it wasn't reinventing the wheel. It was using what was really out here and applying it. And then there's a video here which goes back to that Nova Sun Labs I mentioned earlier. So a really great video that explains the electromagnetic spectrum in relation to the sun. A nice, I think it's under 4 minutes long video. And another NASA image which we've seen quite a bit. And the thing about this image, which I thought was really useful, is it gives you the size of the wavelength. And I think that's an important, piece that, especially with middle school students, it's an intangible concept. How can you make it tangible and relevant? And so tying in, the frequency, the temperature, what's going on, what wavelength are you in the spectrum? And again, you can build upon this to whatever detail fits with your grade level and your time, et cetera. I'm not going to get into this activity. This is where you just basically create a fold-out of a worksheet that's an attachment to the HelioViewer activity that we've done, which is a great kind of foundational part of what's happening. Then when you get to HelioViewer, they should be fairly comfortable with the EM spectrum. And then here's where they choose, sorry, I should finish this piece here, do the tutorial that we had seen with Nova Sun Labs. This is the user guide that Claire greatly presented. And then there's a printable link here if you want to print it off and just have a hard copy in the classroom, because sometimes computers are an issue with getting access, and can they service all the kids at once or not, depending on the bandwidth. So they're getting now into actually exploring the HelioViewer with 3 different sort of investigations. And again, these are open-ended. They're kind of like what you had done. Well, here's how it works, and here's kind of a basic parameter, but what can you add to it to maybe fine-tune it that much more? So a basic introduction to the upper left corner of the HelioViewer site, and then the 3 different activities, which I would love if people want to pilot these with different groups. The first one is looking at sunspots, which is kind of the solar activity element piece with AIA. You've got the photosphere, and then you've got what's happening with the sunspots over time. Are they moving? Which direction are they moving? Are they migrating towards the sun's equator or away? So they kind of get this idea of rotation of the sun, etc. And again, play around with this. I thought with a week might be a good time step to use. The next one was kind of looking at the CME solar flare piece, but having listened to Claire, I'm gonna tweak this one a little bit now that I know what specific wavelengths are a little bit better and which instruments to use. But again, mess around with this one. That ties more in with space weather. And then the last but not least one is that connection to the magnetic field of the sun and how that relates to solar activity. And this one you pull in the HMI, which is actually monitoring the magnetic field changes within inside the sun, and obviously when they poke through the surface of the sun with sunspots, and you can see that connection. Do sunspots occur individually, or are they impaired? So you're kind of like having the students observe and actually see that activity in action. So try to keep it within less than a dozen steps, a thumbnail, so that they know what it should look like, what should be checked, at least from a basic point of view, and they can obviously add or change once they get familiar. So it's somewhat open-ended. And that's the artifact that they're going to be then creating as part of that solar exhibit that they'll put together. They will pick one activity from Module 1, one from 2, one from 3. put it together into a presentation that they curate, and they visit each other's exhibits and learn about the sun in so many different ways, kind of like a jigsaw approach. And then within each teacher guide, there's a differentiation extension. I did a lot of cross-reference with existing resources with the NASA Solar Map. There's a lot of other great resources that NASA has. And then just additional supportive that you can either do as teach yourself about it, teach the kids about it, let them explore, trying to make it completely, comprehensive and open-ended. So that's it. Probably talked way too long and should have asked for questions. So any questions?
This is really great, Jennifer. I can't wait to read through this in detail.
I'm just curious, just in terms of where people are at, I mean, if you have like a day or two, I mean, is anyone interested in just, giving it a go with your students? Because they may find more interesting, amazing ways to utilize it. I'm just curious if there's anyone that's interested in, running it between now and the next holiday break, end of December.
I think Jennifer Miller may have volunteered. I see Tasha's hand in the air.
Yeah. All right.
Jennifer, are you still on the Wigio? So would people be able to find your email there if they wanted to contact you about piloting this for you?
Yes. Let me just go back here. Absolutely.
Also, if you want to put it in the chat box, we can get back to it.
Well, I'm going to do a fast little cut and paste here, if you don't mind, for just a moment. And let me just get this going. So we kind of went through this, that, and get my little visual so no one's falling asleep, right? It's a siesta slot, right?
Nobody's falling asleep.
Go away. Oh, where'd it go? It's not there. Oh, I will cut and paste it into the chat box for sure. And I am really looking for people that once we get the thumbs up from NASA Review to pilot as much or as little of it as you would like. So, and to give you guys support, remotely. So that's definitely an option.
It's really great. Does anybody have any ideas of how, if you've been teaching similar things or comparable things in your classroom already, how something like this might be able to enhance what you've already been doing, perhaps?
From the chemistry perspective, I think it's really exciting for ionization energy and the spectrum. I mean, it's totally applicable. This is what scientists are using now. So I think my kids would be so excited to have their hands on this.
Yeah, sounds good.
But probably it's not in my my standards anymore. So that, again, I need to argue. This is really important, even though it's not on the list.
Time to go rogue.
Are you, is it not in your standards anymore because you're, tell me a little bit more about that, Tasha.
So it's NGSS. And we sit together in a group and we decide, well, what are the main standards we're going to focus on this year, and make sure that we can incorporate the literary standards as well. And so I'm sure that the electromagnetic spectrum, even though it's something I would teach, I'm so excited to teach, it just kind of, oh, that's an extra part. A big thing on our schedule is energy. So I'd really like to know how.
That's where it fits. I was going to say, you should, looking, because I work pretty closely with the NGSS, and I'm like, no, that fits right in with what you need to be doing.
I guess my school, it's a project-based learning school. And so we, as a group of chemistry teachers, get together and say, okay, these are the standards we're going to focus on this year. And so the electromagnetic spectrum is like a nice to know. It's, it didn't fit in this year, but maybe I could argue that next year.
I just have to interject here, because that's the whole thing with NGSS, is it's so easy to look at it just purely from an old school standard point of view, which is mainly the DCI. And when I went to the NGSS training that Ted Willard, who's the man behind NGSS on behalf of NSTA, that's putting together online webinars, et cetera, and his advice for teachers to kind of make this progression from their current standards to the NGSS is to look at the DCIs first. But what I would also really stress is not just the key parts within your grade level or the particular content standard, but really look at the science and engineering practices, which is the whole process of science. And this is the one thing that kind of ties it together. So even though you may not be having EMS spectrum in your grade level standard, but you might be having to do things such as using models, as some other element of the curriculum that you teach. And also the cross-cutting concepts, I think, gives you some freedom to really look for real-world meaningful applications to teach a science that you're teaching and that gets kids interested and engaged in science. That's the whole point about NGSS.
And I would piggyback on that both the NRC, who helped set up the framework that set up the NGSS, and the experts that are working with it all recommend that you actually start with looking at how what you're doing applies or supports the NGSS by starting with the SEPs and the CCCs. They actually tell you to do the DCIs last, because it isn't because it's all about the process of science and what the students are able to do at the end of a bandwidth. So mastery comes at the end of the bandwidth, not in the middle, not after one lesson, not after any of those pieces. That it's actually, it isn't what you know, it's what can you do? Can you do something with it? And then you can kind of pull the different things of what to know out of the middle and insert something else. It's, helping the students be able to actually apply what they're using. I highly, highly recommend the book, Translating the NGSS for the Classroom by Roger Bybee. It is the best $25 you will spend. And he really helps you understand how you can have those conversations both with your colleagues in your own grade band, as well as district-wide conversations, even in looking at what you have and applying. But I found the book absolutely invaluable. Lindsay's sick to death of hearing me out.
Well, Andy, I'm going to jump in too. Because he's the man behind the 5 E's. And the 5 E's, he was hired to do like an article, because he's so well known with the 5 E's, and that's the engage, explore. Sorry, I don't have them memorized, but they're wonderful. And that's what, personally, as an educator, I had used when I was trying to make the STO curriculum be meaningful and to reflect, the spirit of NGSS and enable teachers to have really amazing science that they can bring into their classroom. So he's actually been brought on board to work in a deeper level now with this.
Great. Okay, I will get that.
Tasha?
Again, and I would be glad to support anybody who's wanting to have those conversations and think about, it's the red one on the bottom, the box. Yeah, there, the red one. Perfect. Anybody who's wanting to have those conversations or want to know more about it, I'm glad to share what we've found in all of our research through the SMD. So here's the book. Lindsay put the link in the thing. The first 4 chapters are free online from NSTA in the Learning Center. Anybody can get it and download the first 4 chapters, but it's the back. I mean, you can see how much I've marked it and underlined it and done everything else. I used it to help set up as we look at how we want to start looking at how to incorporate the NGSS in product review at NASA. That has been my Bible in helping communicating to my colleagues about how to think about the NGSS. So it's not perfect, and it's one, but again, Jennifer, and Roger has actually come and done professional development with some of us at the SMD, and he is a very knowledgeable man who really wants to have science education be increased, but also be accessible to all. He really believes in the student. So anyways, that was a whole tangent we didn't need. Jennifer, your stuff is amazing. I'm so excited to see the rest of it. So I know some of you haven't had time to look at it. It did come out in an email to you this morning. All the stuff, the modules that Jennifer shared with us here. So as more come available, and I hope that you will feel that you can share them with us as they come available as well. But it is really well thought out and really well put together, Jennifer, so you should be really proud. All right. Well, we are actually scheduled for another break, but maybe we aren't quite ready to do that yet since we just got back. Do we feel like let's just take a quick poll for everybody. Do we feel like we could have some of do we want to discuss more a little bit with Jennifer or and what she's offered and questions you might have for her or for the group? Otherwise, we can start some of our, I know that I have Wendy and Chris who are eager to share how they've used some of the resources that we've shared this year with their groups, ready to go, and Laura as well. So what's the barometer? What do we feel like would be great?
Say one thing to Tasha.
Absolutely.
As a chemistry teacher for a few years, if you do anything in quantum mechanics, in other words, to identify electron location, and you slip Planck's constant in there, and you have to understand wave mechanics, it fits perfectly on what was just been discovered, that we've just been dealing with. Because that's my direction for electron configuration, is I back it up into the actual quantum mechanics, the values, and tie that directly to the visible spectrum. I even do a lab on the spectrum, and you throw Planck's constant in there with the amount of energy that you can tie directly to the frequencies, you've got to segue right into where we're at right now.
So the next unit that's coming up for us would be energy and like major energy sources that we use. And so I'd be talking about the sun's energy and solar panels. And so then that's where I would be bringing in the electromagnetic spectrum. But I know that the main theme is about calculating energy from chemical reactions. That's what the teachers are going to be focusing on, like stoichiometry, balancing. And so I would be getting into kind of a tangent on using.
But still, you'll still tie the actual amount of energy is directly tied to the frequency of the wave. Right. So even on a solar panel, whether it's a red light, a green light, a blue light, there's different energy values on those lights.
Yeah.
Honestly, Tasha, I don't know how you would do that without talking about the EMS. I think that's where I'm struggling the most, because they have to have a reference point. You have to be able to, I mean, I'm sure you've showed them spectroscopy and those kind of images in chemistry, right? So whether we're looking at molecules or whether we're looking at light coming from exoplanets, and using those chemical fingerprints to be in the light fingerprints, they have to have a point of reference of frequency and what these different energies mean. And especially as you're talking about solar voltaics, they've got to understand that not all solar energy is free to us. That light it isn't just the visible part. That's the part they experience and have a direct correlation to, but that all around us, the invisible parts are what actually makes our technology run. All of those pieces. So in order to be able to understand why a solar flare will cause our cell phones to go out, or why we get so concerned about that, which I would highly recommend going back and watching Dr. Baker's talk last month about the social and economic impacts of solar weather. It's the GEM Space Science Sequence, Mysteries of the Case of Mysterious Events Come to Life. It is really, really great. And also I'm going to talk a little bit about our next month presenter, who actually makes what are called solar suitcases to go to different places without energy sources to be able to run electricity next month. And so I'll talk a little bit about that at the end. But I don't understand how you would be able to talk about energy and energy flow without talking about the EMS, about any of those pieces.
For me, it's just like a total shift, because we sit together and we plan, what are we going to teach this year? And how is it that, yes, I teach that every year, and how is it that now it's off the plate? And somehow it's like people are telling me, so what I'm hearing is, why are you teaching so much physics when I'm bringing the solar panels in? This is a chemistry class. It's not a physics class. Why are you getting so much into, and it blows my mind that, what? This is kind of basic to chemistry. But somehow it just with all of the literacy, our school's really big into literacy, and we're just cutting pieces out, and it's strange to me.
It's sometimes hard too and that's just because that's been the trend that we've gone through for the last 50 years, is that science is compartmentalized. I'm always blown away at how many times I have to have the conversation that the chemistry that we see in the classroom is the same as the chemistry that happens on the sun. And I'm always flabbergasted that people don't understand that somehow that chemistry is way, way different than, the chemistry, the same, I don't know. I'm like, well, they're all elements and they still function the same. So I think that kind of thinking, it is a mind shift like you're talking about. And if people don't work with it, they don't understand how you're teaching chemistry when you talk about biology. You were talking about physics and quantum mechanics when you're talking about chemistry, because it doesn't function without those things. is all one thing. It is not, you know, you can't just do biology. You can't just do physics. You can't just do chemistry. It's all connected. And that is hard. Those conversations are very difficult.
A bit like saying, how can you just teach physics without teaching math?
Right.
You know, they go hand in hand. Now, I understand your problem and your challenge, because when you have to try and, like, the very nature of school is that you do put things into boxes and you don't teach the same thing over and over in 3 different classes. But there are definitely very strong and important arguments to be had in favor of overlapping between chemistry and physics. And it's not really physics, it's science, you know. I mean, so for example, to my mind, the bit that is quite relevant here is the atomic structure of atoms and the you know, the energy levels that they go to in order to produce the light that gives us the wet pass bands and the emission lines that we study with these. And it's a physical construct because you're studying radiation and you're studying that aspect of it, but it's the chemistry of the atoms is what gives us, what results in the physical response. So it's all one big piece.
I have been able to use, even though I'm really encouraging the other teachers, they're younger, I think, and so they're just thinking more in a traditional way. And so I brought in the NEED resource that I'm going to talk about later. And there's a lot of physics in that. And I think like the basis for me that I'm able to even use that kind of thing is like right away, they'll show readings with the atom on it. So I'm like, yes, here's the atom. Here's the parts of the atom. Like they're totally interconnected. And now we need to show more the connection between the physics and the chemistry, and that they combine together to give us the products and allow us to do these kinds of applications.
And honestly, that will stand to your students so much better in the long run. Like that's what they're really going to thank you for. I was at an open day at the weekend and I had a mom come up to me and ask me, was it a physicist or an engineer who came up with the ideas that you would put a magnetometer on board a satellite? And I couldn't answer her. I was like, it's not like the physicist makes A, B, and C decisions and then hands it over to the engineer. Like this is it's all pieces of, it's one big blob of knowledge, and then everybody contributes and receives aspects of that knowledge in different amounts. Now, there's definitely pieces of chemistry that I shudder when I think about them. If you ask me to talk about organic chemistry, you will see a Claire-sized hole in the door. But there are definitely pieces of chemistry and of physics where there's very significant and really important overlap. The same, as I said, between physics and math, or between science and English, where you have the writing component. I was never taught how to write a science paper. After 16 reviews of my first paper, I learned how to do that, but that would have been a nice lesson to have when I was in school, you know. So but it doesn't get over your challenge of having to convince the rest of your staff that this is important.
Wow. Tasha, this is a common problem, and I don't know in public school systems in the U.S. What happens is you try to do a project like the MMS wavelength, NASA wavelength projects. I've been trying to introduce this to teachers all across the state, and it doesn't fit in their scope and sequence. And this is a very common problem. And what happens is the teacher wants to be creative, but they can't. Maybe they feel a lot of pressure. And so what I've done, Tasha, and you might consider this, is reach out to your engineering, arts, fine arts teachers and technology teachers to support you. So when you're talking about energy, have them maybe work with you, so that, because you don't have time. And I think a lot of people maybe don't understand the pressure that these teachers are under, like with the standardized testing here in the US. It's very stressful. And so when you come with a new idea and a new approach, that's the 5E instructional model, and that might, you know, a lot of people don't even understand instructional models or learning theory. They want project-based learning, even though project-based learning could even fit in as an elaboration component in the 5E model. This is an issue that I I've had, I have encountered your pain, not just me, but the teachers I've counseled. So what we've done is we've formed after school science clubs to accomplish what I'm trying to accomplish this year. To do a lot of the projects that this particular group, in fact, the Sally Ride project, I had to do that in a technology class. They were studying about, the sun even.
Mm-hmm.
But it didn't, a lot of the activities that we're talking about here, it was hard for me to get the curriculum coordinators to buy in.
Right.
Because of the time piece.
Right.
I'm just throwing that out so that people are aware of the reality of what's happening on the ground in a public school system.
Right. Thank you. So after school, you can get something started, right? Everyone is contributing, volunteering, and then maybe it takes off during the school year later on.
Yes,
Yeah,
and that's, go ahead, sorry.
Because you're at a project-based learning school, right, Tasha?
Yes.
Is that kind of focus? So you have a natural fit, and just what Jennifer had mentioned is exactly the reason I chose personally as an educator. You just see this potential for how students can really learn, and you do have your hands tied in the classroom with all this stuff that keeps coming down, keeps changing, but all you need is one person in your school, and I agree with get the STEAM approach. I worked with my art teacher on the EMS deal because she's doing art and they're doing painting. It's like there's these natural fits. So just find one person, do a small unit, and have it be project-based with that kind of 5E model. That's just good teaching.
Right.
I mean, I don't even want to tell you that. That's just,
And
follow what you're
doing. Way fun.
Yeah, and the other cool thing is I did a lot of just, things like the Siemens We Can Change the World, the Disney Planet Challenge. Find some of these opportunities that are out there, and the kids can see that, okay, we're not in isolation doing this. There's other groups and people, whether it's in your classroom. I did mine as an after-school environmental club. So don't give up is my point. And I agree with what Jennifer says. You just got to keep creating the reality that you know is right. Keep it small and simple first. Maybe one class, one quarter is your pilot, what works, what doesn't work. I brought in a lot of expert parents, depending where you live. It sounds like you might have a lot of technology know-how with parents that want to come in and be a guest speaker. Who can you have support so that you're not doing this in isolation?
Right. Thank you.
These are important things, and that's exactly why we have this group, so that we can bring these questions and these ideas to them and share those resources with one another, so that we can make it better, for sure. All right. Shall we move on, or do we want to continue to talk about this a little bit? Well, why don't we go ahead and move on? Our next part of our, why don't we do a couple, and then we'll take a quick break, and then we can come back and finish up, because our time is going, but this is not because we've done anything wrong or any of these. Is exactly what this time was for. It makes me even sadder we don't have 2 days, because they're just so rich. The conversation is so rich. So we do have the next part in our teacher resource sharing is how the different things that teachers have done in their classrooms this year. And I went in no particular order than in the order that you responded. So Wendy, are you prepared to share with us what you've been doing with your kids this year?
Sure.
Awesome. Thank you, Wendy.
I'm ready. Want me to take off?
Take off. It's all yours. The platform. The ball is yours. In your court.
Okay. Let me see if I can do this now. There. Can you see that?